Hi students, in this session let us discuss about basic properties. Means that elements. For example, if I divide total networks, again everything is going to be linear, lumped, passive, bilateral, causal, time invariant systems. Basic elements are we have to write properties. What are the different properties which we are going to consider? Okay, basic properties can be divided into two, active and passive. Actually, people feel they know much about active passive. No, just wait. Okay, basically here we are going to have resistance, inductance, capacitance, mutual inductance. Here we are going to have independent sources, dependent sources, everything you know. For example, we should not write resistor here, we should not write inductor here, we should not write capacitor here, but we can write resistance, inductance, capacitance. Basically in the physical world, only resistor is impossible to have. Okay, for example, if I say this is resistor, okay, so our machines lab rheostat, for example, we will have wire like this, air core. Okay, so for example, this is having some resistance here. Okay, so the practical resistor will be the combination of resistance, inductance, capacitance. For example, between turn to turn, conductor in between insulation, so capacitance will be there. Okay, so the moment some current is flowing, inductance also will be there. We are going to discuss in detail very soon. So passive elements, resistor, no. Resistor is a practically physically existing element. Okay, but resistance is a property. So for example, inductor will be there. I know inductor will be there. So inductor can be modeled with the resistance and inductance combinedly. So just to come out of the notation like passive elements, properties in the sense means here, for example, if I write resistance, okay, what does it mean? Ideal resistance. It is not a practical resistor. Okay, so let us see the difference. Practical resistor is going to be the combination of all the properties of here. Okay, and practical inductor will have all the properties of here, but if you think of individual property is going to be ideal, means that combination of resistance, inductance, capacitance is going to be physical system depending upon the domination. For example, practical rheostat is there. In this, if resistance is completely dominating compared to inductance and capacitance, we are going to model practical resistor as resistance only. Okay, so for time being you may not understand this, but in the end of the process definitely you will understand. Anyway, forget about it. Let us define what is active, what is passive. See here, don't write each and everything in the notes, not required. Trust the brain. It is going to be the mind game. If anything need to be written, I will tell you. Okay, so what is active, what is passive? Let us define. For example, if I define active, what people say, which deliver power. How nonsense it is, right? So basically, which deliver power, which deliver energy cannot be active here, cannot be of anything, because means by conservation of power or conservation of energy, which we learnt in 8th standard or 9th standard, what do we know? Power or energy can never be damaged, destroyed, can never be created. Conservation of power. So in this case, means who will deliver power? Getting my point, right? So power cannot be delivered, no. Energy cannot be delivered, no. So active element, we should not write or we should not say which delivers power, because if I think of a generator, see, my intention is machines, power systems, power electronics. So this is the supporting system. So actually some people may feel that means, is it network theory? No, it is network theory only. Okay, network theory has to be dealt like this only, such that we have to build from basics, such that at the end, while reading machines, power system, power electronics and all, we will get the clarity. Okay, so anyway, active means that nothing will deliver power. For example, generator, is it delivering power? No. But what it is delivering? It is delivering electrical form of power by consuming mechanical form of power. Forget about it, battery. Okay, so battery, is it active or passive? Active, because it is delivering electrical form of power by absorbing chemical form of power. Okay, so which delivers electrical energy. Getting my point, right? So we are electrical engineers. So we have to see everything from electrical point of view only. So electrically, if something is able to deliver power. For example, transducers will be there. Okay. So in measurements, transducer will come. Mostly I am going to consider that. I am going to analyze that. But anyway, transducer is there. Okay. So thermal to electrical. Okay, so basically transducer in the sense any other form other than electrical to electrical conversion, if it happen, we call that as a transducer. Okay, for example, thermal energy is there. Thermal energy is converted into electrical form. Electrical form means that it's a generator or it's a active element. Okay, for example, some pressure is there. Some pressure, that pressure, if you convert that into electrical signal, that is going to be active element only. Okay, anyway, now the definition I will tell you first. You can make a note of it. Okay, active element means that it does not mean which delivers electrical power also. No. Okay, you please write it here. Active element means that which can deliver. For each and every word there is a meaning. Okay, which can deliver average positive electrical power from, if you consider from T10 into minus infinite to plus infinite. Okay, let me repeat again here. All of you have to note it down. Okay, means active power means that which can, it is not which deliver, which can or which is having the ability to deliver average positive electrical power from T10 into minus infinite to plus infinite, if you consider the time. For example, in this session we are going to discuss only about active. We'll discuss about passive in the next session. Now, which can deliver. For example, we came to know that battery is battery is active. Okay, for example, one battery is there which is having 10 volts battery. I connected resistance. Compulsorily I have to connect resistance. Why, you will come to know soon. For example, this is 5 volts battery. Okay, and this is 1 volt. Now, how much is the current flowing here? 10 minus 5. Of course, though I did not deal till now Ohm's law, but anyway, Ohm's law already you know. 10 minus 5 by 1 is going to be 5 amperes, right? Okay, so what is the power delivered by this? Because current is coming out of positive terminal, means that power is going to be delivered. Current is entering into positive terminal, means that power is absorbed. Okay, because in the previous session we have seen what is power. Voltage multiplied by current entering into positive terminal is power, or voltage multiplied by current leaving from positive terminal is power delivered. So for example, how much is the power delivered by this? This is going to 5 amperes, no? Voltage multiplied by current, 10 into 5 is going to be 50 watt is the delivered power. And what is the power absorbed by this? I square R. So 5 square into 1, I square R. Basically, though I am using I square and all, I square R and all, in future you will come to know everything. So 5 square into 1 is going to be 25 watt. Now my point is here. Now 50 watts of electrical power is delivered by this. In this 25 watts is absorbed by this. In this remaining, because 5 amps is entering here into positive terminal, 5 into 5 is going to be 25 watt. So point here is this battery, is it absorbing or delivering? Absorbing. So should I call this battery, 5 volts battery, as a active or passive? It is absorbing, no? Getting my point, right? So though it is absorbing in this case, but it is having the ability to deliver. No, for example, if I connect to some other system, it is disconnected from here, it is connected to some other system. If I connect, for example, 5 ohms resistance, then current, it is having the ability to deliver, no? So which delivers electrical form of power is wrong. What is right? Which is having the ability to deliver. Actually, in this present system, actually it is absorbing, but it is having the ability to deliver. You are not utilizing it. That's up to you. Okay. So what is active element? Which can deliver, which is having the ability to deliver, electrical form of power. Now, let us think of, you know inductor, I know inductor. Okay. So inductor or capacitor or inductance or capacitance. For example, inductance, of course, in future we will deal. Anyway, you know that inductance and capacitance will take energy, will store that energy. That's why we call them as a energy storage elements. Okay. For example, inductor, this is inductor. Okay. And I spend some energy here. Okay, equations and all will come baad mein aayega. Okay, so this is particular inductor. In this inductance, or for example property inductance, I stored some amount of energy. Okay, at t less than 0, for example, I stored some amount of electrical energy. Over. Now, I kept this particular energy here. And after that, maybe after 5 hours, or 10 hours, or after some time, 1 million years. 1 million years means if I consider this energy stored will be there, no? That energy stored will come back, no? For example, capacitance is there. For example, this is capacitance. Capacitance can store energy. So you supplied energy. It is stored here. And for example, if I connect some other resistance here, by disconnecting that, if I connect some other resistance, it will deliver power, no? Electrical power. So inductance and capacitance means whenever they are delivering the stored energy, I can call it as inductance and capacitance as active or not? No. That's why we have to take from t10 into minus infinity to plus infinity. Means that, for example, inductance is there or capacitance is there. This is going to be capacitance. Okay. So maybe now, or maybe t10 into minus 10 or minus infinite, somewhere in the history, you might have stored electrical form of energy. And somewhere in future, you are going to take same electrical form of energy. So from minus infinite to plus infinite limitations, if you take, how much is the total electrical power delivered by this? 0. Because it is taking electrical power only and it is giving electrical power only. So inductance and capacitance cannot be active. So what is the definition here? Now go through the definition again. What is that? Active means that which can deliver any property which can or which is having the ability to deliver, average positive electrical power. From when you consider what is the average, in order to calculate average, if you consider time constant as minus infinite to plus infinite, the moment if you include minus infinite to plus infinite, inductance and capacitance cannot be active elements. Okay. So anyway, with this active element definition is over. At least we are able to understand now what is active. If anybody say active element which delivers power, rho. Which delivers electrical power? No. Which can deliver electrical power? No. Which can deliver average positive electrical power from t10 into minus infinite to plus infinite is active. Okay. Now this can be divided into, and about linearity and non-linearity, these can be linear, these will be non-linear. Outside linearity, one concept is there, that concept will come in future. For time being, let me continue. So active element, I can divide active or sources also I can write. Sources of electrical power, blah blah blah, whatever we discussed. So active elements can be divided into independent and dependent. Independent sources and dependent sources. Okay, so why I am directly taking this without having any practical approach? Because what is our intention? Practically, physically existing electrical system is there. Okay, so this electrical system has to be modeled, right? That is the purpose. That's why lecture by lecture, one by one you have to follow. Don't rush into the things, not required. Relax, be cool. So for example, physically one existing electrical system is there. I have to convert that into mathematical model now. Okay, so by using all these properties, combination of all these properties, I am going to model the physical existing system. After that, physical existing system is not required. So by using this only, applying KCL, KVL, mesh model, blah blah blah, we are going to get the conclusion. Okay, so these are the basic properties, and by combining these basic properties, physically existing system will come. Okay, leave about it. Now independent sources, dependent sources will be there. And independent sources, voltage source, current source. Maybe you might know, you might feel that you know what is voltage source. No, just follow me. Okay, means independent voltage source will be there. Independent current source will be there. Again, our electrical guys feel that independent voltage source is available in practice, independent current source is not available. Again, that is also wrong. Combination of properties will give you physically existing system. Leave about it. Now this particular voltage source we can show like this, and current source we are going to show like this. Okay, I see I'm using small case letters. Why? Small case letters is going to be superset, capital letters is going to be subset. So it can represent DC also, AC also. Okay, so in saying that, as we discussed in our previous session, this terminal is going to be at more potential compared to this of V. That V can be negative. Getting my point, right? Now, for example, what is source? What is independent source? At the end of this discussion, you will get beautiful conclusions, wonderful conclusions. Just stay tuned. Okay, so means independent voltage source will be there, current source will be there. Okay, for example, independent voltage source. Independent voltage source. What is meant by independent source? Independent source. For example, means if I ask you one question, what are the waveforms that can be source waveforms? What are the waveforms that can be source waveforms? For example, this voltage is constant. Okay, so this is going to be V, which is going to be constant with respect to time. Okay, so you have to tell me, or at least you cannot tell me because it is not offline, but you have to identify which can be source waveform, which cannot be source waveform. Then only you will understand what is source. For example, if it is constant, what does it mean? What does it mean? It is going to maintain this much amount of potential constantly. For example, this is 10 volts. 10 volts. So from our basic point of view, if I think of the charge, this is going to be a small test charge. Okay, small test charge. For example, in order to move it from test charge from here to here to here, I have to expend some amount of energy. That expended energy per coulomb of charge is nothing but voltage. So that particular voltage it is going to maintain constantly here in a source. Okay, so this can be source waveform or not. Think. So this is A, for example. This is going to be, again, this can be source waveform or not. Wait, think. Or for example, this can be source waveform or not. Okay, now for example, this is V, this is B, this is C. Or let us see, this can be source waveform or not. Okay, so this is going to be, now see here, is this source waveform or not? DC source. Most of the members accept it. And is this a source waveform or not? Electrical guys, infinite source, national grid, your ceiling fan, everything will be operated by sinusoid only. So is this a source waveform or not? Most of the guys accept. Is this a source waveform or not? People start thinking. Okay, this also can be source waveform. I will tell you, just stay tuned. Now, is this source waveform or not? You think no, but it also can be source waveform. Basically, this is normal DC, this is repetitiveness is there, this is repetitiveness is not there, but still this also can be source waveform. Okay, so let us think of what are the things those can be source waveforms, or what are the things that cannot be source waveforms. For example, what is source definition? For example, if I have a voltage source, and what is the purpose of having voltage source? It is about to be connected to a system. Okay, for example, I am going to connect this to a system. Okay, so this is going to be the switch. Okay, some other system. Now when I am going to connect this source, maybe at t equal to 0. Now let us see the source definition. For example, I am going to close the switch at t equal to 0. Okay, so at t less than 0, in the sense prior to, you have to make a note of it, prior to connecting the source to the network or system, in the sense at t less than 0, all the instantaneous voltages across this of source should be known, and after connecting the source to the network, it has to maintain pre-specified voltages independent of loading condition is the source. I will tell you, just wait. Okay, so prior to connecting for example, let me directly take this. Okay, for example, prior to connecting this particular source to the network itself, I know that at t equal to maybe 1 second, voltage is 10 volts. At t equal to 10 second, voltage is maybe 100 volts. At t equal to 20 second, voltage is 200 volt. At t equal to maybe 80 seconds, voltage is minus 15 volts, for example. So all instantaneous values of voltages I should know prior to connecting the network. Okay, so at t less than 0 only this particular complete thing I should have in my hand. And once you close the switch, whatever may be the load it is, it may be short circuit or open circuit or whatever it may be, whatever may be the load it is supposed to maintain pre-specified, in the sense at t less than 0, already on paper my same graph is there. Okay, so this graph should be given to me prior to connecting the source to the network. Okay, and once you connect, it has to maintain the same graph independent of the system. That is the source definition. Now you will get one more thing. Okay, for example, if it is random signal, for example, this is not source waveform, it is random signal now. Okay, so can random signal become source waveform is the point to be noted. Okay, for example, means my conclusion is very simple. Random signal in the sense we don't know next instant what is going to be the value. Okay, so my conclusion is random signal cannot become source waveform, and source waveform cannot contain any information. Okay, so this is the conclusion. You have to make a note of it. Please make a note of it. What is that? Means my random signal cannot become a source waveform, and source waveform cannot contain any information. For both the things, let me take this only, then you will get the clarity. Okay, for example, this is random signal. Okay, so this random signal cannot be source waveform. Why? The moment it is random signal mean that at the next instant how much will be the value of this, we don't know. Okay, but what is source? Everything should be known prior to connecting the switch to the network only. So random signal cannot become source waveform. Okay, because randomness in the sense at the next instant how much is the value, we should not know. Okay, what is source? Everything should be known. So the moment everything is known, it cannot be source waveform. Sorry, the moment everything is known means that cannot be informative signal actually. Now let me come back. Can source waveform contain any information? For example, can this have any information? No. 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 Because for example, just for example, means for example I have AC here. Okay, so AC I set to 20 degrees, for example. I set to 20 degrees centigrade. Then for example, if the temperature of this room is less than 20, what will happen? Means feedback system will go, controller will come, it will increase the temperature of this room to 20 degrees. And if it is more than 20, automatically it will reduce. Feedback path will be there. Okay, for example, if I already know everything, means that okay, tomorrow at morning 9 o'clock, temperature of this room will become 18 degrees. Tomorrow at evening 5 o'clock, temperature of this room will become 25. Maybe late night of tomorrow, maybe temperature will become 10 degrees. Okay, so if I know every information completely, tomorrow what is going to be the status? Why do you have feedback form? Getting my point, right? So focus here, please, relax. See here, for example, in order to maintain the temperature of this present room to 20 degrees, if it is more than 20, it has to be reduced to 20. If it is less than 20, it has to be increased to 20. So this is the information, right? To maintain the temperature of this room to 20 degrees, information, what is information? Whether it is more or less. If it is more, how much is more? If it is less, how much is less? That is the information. Okay, for example, if everything I know, prior to connecting the switch only, if everything I know, means that, okay, means at morning this time, means temperature I know, at afternoon what will be the temperature I know, evening what will be the temperature I know. If everything is known, that is called as information. For example, you are tuned to me now. Why? The next topic, the next point, what I am going to deal, you don't know. That is called information. For example, in this session, what I am going to deal, if everything is known to you, why to join here or why to watch me here? Okay, simple thing. What is that? Source waveform, complete waveform should be known. All instantaneous values should be known prior to connecting the network to the, prior to connecting source to the network, and after connecting means independent of any system connected, any network connected, it is forced to maintain the same. That is source. So conclusion is source waveform cannot have information. Our random signal cannot become source waveform. In the sense, if you have information means that it cannot be source waveform. If it is source waveform means that it cannot have information. Okay, so this is all about source. This is all about source. Now means maybe why don't we consider this type of source waveforms in network theory, network analysis? See here, this can be easily calculated or not. Yes, this can be mathematically, one function can be written or not. Yes, mathematically one equation can be written or not. Yes, mathematically can I write? No. What is network theory? Mathematical representation of this. For example, means if source waveform is this, for example, if source waveform is this, under that condition, we have frequency domain analysis is there, time domain analysis is there, so much of analysis will be there, in control sections, Bordeaux plot will come, so much of things will come. So, even if you have in practical case these conditions, we will convert into so many sinusoids by using Fourier. Those many sinusoids we will give to transfer function, and we draw Bordeaux plots and all. This is a different story. So mathematically speaking, I cannot write any equations for this. That's why we don't have this in our network theory. Mathematically we can write equations. So one thing you have to understand here, the network theory is all about mathematical representation of practical system. If something is you are unable to mathematically represent, means that we will do at later stage of time or in other subjects is the meaning. So this is about sources. Now means about independent voltage source, independent current source. Okay, we will deal again separately.